Tom, you might find a lot of hits, thousands of hits, because everybody is coming in and asking, what's the best way? What is the best way? What is the best way? And my answer to it is always, it depends. It depends. Tell me more. Tell me who you are, where you are, and what you're trying to do. Here's a quick example, a very simple one. Look at this query. It's a trivial query. Join two tables together, ID equals ID, and a where clause. Table T1 in this example is very large. How large is it? Imagine the largest table you can think of, insert one more record into it. It's that big, right? So it's bigger than you can imagine. The where clause against it, where small underscore distinct equals some bind variable, returns much of the table. Maybe that column small distinct only has 5 unique values. So when we do this where clause, it will return 20% of the rows in this very large table. T2 is also a large table. Now, what is the best way for the optimizer to access the data and return it to us? Here's 2 possible query plans. The first one, close to me, is a full scan of T1, followed by a full scan of T2, and a hash join. The other one, further away, would have us use an index on table T1 in order to satisfy the where clause on small distinct equals X, find the 20% of the row, and then go and use an index against table T2 to retrieve the information from there and give the answer back to the end user. How many people believe that the hash join is the right way to process this query? Quick show of hands. Not very many. How many people think the nested loops join is the correct way to process this query? Again, not very many. How many of you will never raise your hand no matter what I ask? The whole room. Okay. You must know there's a trick in here someplace. You know there must not be a best way. Let's turn on SQL Trace, run these 2 queries, and look at a TK-prof. Well, here's one that compares the 2. It's obvious now which one is the best way. The full scans and hash joins took 9.32 elapsed seconds of time, did very few physical IOs, disk, did very few logical IOs, the query column. The nested loop join one, though, that took significantly longer, many, many times longer. It did many, many more physical IOs. Why? Because it was accessing so much data. T1 and T2 don't all fit in the buffer cache. And when it was accessing it through an index, it would have to get a block, put it in the cache, find out there's no room in the cache, flush out some other block, but then we'd need that block again later in the same query because we're reading the data in a very scattered fashion. So obviously, the hash join is the best way, unless I gave you this TK-prof. I turned on SQL Trace and ran the 2 queries, and then turned SQL Trace off. Now all of a sudden, the nested loops join looks to be the best way. Why? That's because we only fetched once. I was an interactive application. My goal in the second screen here was to get the first 10 records on the screen as fast as possible to the end user. With the full scans and the hash joins, to get the first record out of the hash join query, we have to full scan T1, apply the where clause to it, find the 20% of records, hash that into memory, and then we can get the first row out of T2. The end user has to wait for that first full scan and hash to take place prior to getting the first record. With the nested loops join, they get it almost instantly. The index finds the first record in T1, joins it to a record in T2, and the data is back to them incredibly fast. This is the right query plan in a stored procedure. Stored procedure doesn't return control until it's finished. Unless it's a stored procedure that's a pipelined function, in which case it starts returning data to the client immediately as soon as it starts calling pipe row. So I can't even say this query plan is the best way to process this query when it's in PL SQL. The answer is this is the best query plan when it's in PL SQL, and the PL SQL is not a pipeline function, right? It depends. I needed a lot of context to figure out which is the best plan. Interactive application, the nested loops join is probably the best plan. Batch process, something to run in the background, the full scans and hash join is probably the best plan. You have to ask lots of questions to figure out which is best. It takes that context. So this is that quote again. It's easy to forget the context for which any given practice was promoted as best, and therefore apply it in some inappropriate context. Indexes are best. Everyone knows that. Everyone's taught that from day one, and they get stuck on that. In order to tune queries, look in $SQL for queries that are doing full scans. We need to tune those. Full scans are evil. It depends. It depends on the nature of the query. You need to have a little bit of a context. What are you trying to accomplish, along with the other inputs, to figure out what is the best way. It takes understanding too. This is why, in order to receive best practices, you have to know Oracle inside and out, you have to know PL SQL inside and out, you have to have access to mentors, and so on. Take, for example, a really simple question. How do I tune with TK-Prof? So I got this question on Ask Tom, and I know what the person asking it wanted. They wanted a 10-step solution so that they could take a TK-Prof, do step 1 through 10, and everything would be better. I answered, if there was such a 10-step process, I would have patented it, I would have developed the software for it, and I would be retired, right? There is no 10-step process. The first thing, in general, in a TK-Prof, in general, what you're doing is you're looking for the long-running query. If I tune that long-running query, things will probably go faster. But what if you can't tune that long-running query? Now you have to go back to the application and look at what the application's trying to do and figure out, did they use the right algorithm, the right approach in order to do this in the first place? Maybe tuning the SQL in the TK-Prof isn't the right answer. It's going back to the application and changing the way it interacts with the database. But let's say you were going to try to tune with TK-Prof. This might be the approach that you would take. You get lots of bits of information when you turn on that SQL trace, run the query, and generate the TK-Prof report. One of the things you get is the query itself, right? Another thing you get is the actual answer that the query gave. So I can see what the query was, I can see the output. The answer to this query was approximately 700,000. So that was the answer. We were counting something. We get to see details about the execution of this query. Well, we can see that it took 99 CPU seconds, and it used 262 elapsed seconds. So if we were watching this on a clock, it took almost 4 minutes. It took 100 CPU seconds to execute. It did lots of physical IOs, 1.8 million, and it did lots of logical IOs as well, 1.8 million. We get to see details down to the individual steps of the query plan itself. We can tell you how long each one of those steps took. So I can not only tell you how long the query took to run, I can tell you how long each individual part of the query took to run. I can also